Greetings. So let's take a look at another type of U-substitution scenario. So here frequently substitution can be used when we have a linear function times the square root of another linear function. In terms of algebra, so I can't simplify this algebraically, but I can simplify something that looks like the integral of, let's say we had the integral of u to the 3/2 plus u times the square root of u du, where I only have one item underneath the radical. I can go ahead and I can use some algebra to distribute and simplify and find the antiderivative of that. And so that's our goal in this kind of simplification problem for U-substitution, is that I'm going to try to get rid of the multiple terms inside of the radical here, and I'm only going to try to get one object, one element inside of it. Okay, so let's go ahead and get started. All right, so what I'm going to do is I'm going to set u be equal to the linear function that's inside the square root. So I'm going to let u be equal to x plus 6. Okay, now, if u equals x plus 6, that means that we also know that x must be equal to u minus 6. Does that make sense, hopefully? All right, I just isolated x there. All right, so now, as with the other U-substitution problems, I am going to take the derivative of our u statement, so du must be equivalent to dx. All right, so now let's look at our integrand. So here I have the integral of x is equal to u minus 6. So I'm going to substitute u minus 6 there for x. And then I am going to substitute, instead of square root of x plus 6, I am going to set x plus 6 equal to u. And we also know that we've got this dx here, and dx is equivalent to du. So I am going to substitute, instead of dx, it is going to be equivalent to du. Okay, so I've substituted for all the components that have x or dx, and I've turned them all into variables with respect to u's. Okay, so now I can do a little bit of algebraic simplification. So this is the integral of u minus 6 times u to the 1/2 du. Okay, so I can distribute u to the 1/2. So I get u to the 3/2 power, because 1 plus 1/2 gives us 3/2, minus 6u to the 1/2 du. Now I can go and take the antiderivative of both of those terms. So the antiderivative of u to the 3/2 is going to be u to the 5/2, add 1 to your exponent, times the reciprocal of that new exponent, which is 2/5, minus 6 times, now I'm going to add 1 to my exponent, so that gives me an exponent of 3/2 times the reciprocal here of that new exponent, which is 2/3, plus c, because I'm looking for all possible antiderivatives. Now, my final step is I don't want my answer in terms of u, I'd like my answer in terms of x. So I'm going to back substitute. So what I have is 2/5 times x plus 6 to the 5/2 minus, that would give me 4 if I simplified that, times x plus 6 to the 3/2 plus c. And that would be our final result. So this is a slightly different usage of substitution to take something that was complicated and make it a little bit more simplified, where we could do some algebra to find an antiderivative. Check back in the next video for a couple other examples. Especially, we're going to take a look at examples with different with limits of integration. So looking at our definite integrals.